Welcome to The Explainer. So today we're diving into what's really the next major evolution of AI. We're moving past simple conversation and into a world where AI can actually get things done. We're talking about agentic AI.
Look, we're all pretty familiar with chatbots by now, right? They can answer our questions, help us write an email, even whip up an image. But what happens when that AI gets a set of hands to go with its brain? What happens when it can actually take action in the digital world for you?
And that is the fundamental difference we're looking at right here. A standard chatbot, you give it a prompt, it gives you one answer back. That's it. But an AI agent, well, it's designed to take a goal and then figure out a whole series of actions to get there, learning and adapting as it goes. It's really the difference between asking for a recipe and having a chef walk into your kitchen and actually cook the meal for you.
Okay, so let's break this down. What exactly is an AI agent? Let's get a really clear definition on the table.
You know, I love this analogy because it's just perfect. An agent is an autonomous system. You give it a goal, and it perceives its environment, reasons about what it needs to do, and then takes a whole sequence of actions to achieve that goal. It's not about a single response, it's a persistent, goal-driven process that keeps going until the job is done.
All right, so let's really get into it. Let's look under the hood. What makes an agent actually tick? I mean, how does it think? And how does it interact with the world around it? So, at the very core of an agent's mind is this, well, brilliant framework that keeps it from just making stuff up, hallucinating. It's called REACT, and it's designed to keep the agent grounded in reality by basically forcing it to constantly check its work.
This REACT framework creates this incredibly powerful loop. First, the agent has a thought about what it should do next. Then, it takes an action based on that thought. And finally, it makes an observation of the result. What happened? Did that work? And based on that new information, it loops right back around to the next thought.
And this visual just nails it, right? Thought, action, observation. It's this exact cycle that keeps the agent from, going completely off the rails. It forces it to check the facts on the ground before it makes its next move, which makes its behavior way more effective and, honestly, a lot easier for us to understand.
Now, a brain is great, obviously. But to actually do anything in the world, an agent needs tools. It's just like a chef. They might know every recipe in the book, but without knives in the stove, they can't cook. For an agent, tools are its kitchen.
And what's so cool is the sheer variety of these tools. We're talking about anything from a simple web search to the ability to write and execute its own code. It could be tapping into a private database or connecting with literally thousands of different APIs out there. These tools are what give the agent its hands to actually get things done in the digital world.
So, look, a single agent with a mind and some tools, that's powerful for sure. But where things get really mind-blowing is when you move from a single agent to a whole team of them, all working together on a single goal.
And honestly, this is the perfect way to think about it. For really complex problems, one generalist agent just isn't going to cut it. Instead, you can build a specialized crew, where every single agent has its own specific role and its own set of expert tools.
And this right here is what we call a multi-agent system. It's basically a structure where different agents, each an expert in its own little domain, collaborate. You'd use this for tasks that are just too big for one agent, or that can be broken down into different streams of work that need to happen at the same time. So how do you manage a team like this? Well, the most common way is with this orchestrator-worker pattern. Just think of it like a project manager. The orchestrator agent gets the main goal, it breaks that goal down into smaller, bite-sized tasks, and then it assigns each one to the right worker agent for the job. Once all the workers are done, the orchestrator gathers up all their results and puts together the final answer.
All right, so this all sounds great in theory, right? But what does it actually look like when you apply these ideas to solve real-world business problems?
One of the most powerful places we're seeing this today is in software development. Imagine an AI that doesn't just give you a snippet of code, but can take on the whole programming task from start to finish.
And this is pretty much what that pipeline looks like in action. First, a planner agent breaks down the feature request. Then, a coder agent gets to work right in the actual code. A test runner agent then executes tests to see if it even works. If it doesn't, a debugger agent jumps in, reads the errors, and tries to fix the code. And finally, a code review agent checks the whole thing before flagging it for a human to give the final approval. It's literally a full digital software team.
Okay, but with all this incredible autonomous power comes a huge responsibility, right? Safety and control become maybe the single most important piece of this whole puzzle, and we absolutely have to get it right.
I mean, this is the crucial point, isn't it?
When you give an AI the power to actually do things, to take actions, you're introducing a whole new world of risks that we have to actively manage. It's not just about getting the right answer anymore, it's about preventing the wrong actions.
And these risks are no joke. We're talking about an agent accidentally deleting critical data, or getting stuck in some crazy expensive loop just burning through API credits and cache, or even being hijacked by malicious instructions hidden on a web page it visits. These aren't just theories. These are real engineering problems we have to solve.
So what's our best defense? Right now, the single most important safety mechanism we have is called human in the loop, or HITL for short. And, well, it's pretty much exactly what it sounds like.
Think of it like a mandatory supervisor check. Before an agent can do anything high stakes or something it can't undo, like sending money, deleting a database, or firing off a critical email, it has to stop. It has to pause and get a thumbs up, an explicit approval from a real person. This makes sure the agent never crosses a critical line without our permission.
All right, that was a lot, so let's do a super quick recap of the 4 biggest ideas we talked about. First, the AI agent. That's your autonomous system that acts to achieve a goal. It thinks using that REACT framework, that whole thought, action, observation loop. For the big jobs, an orchestrator agent can manage a team of workers. And most importantly, human in the loop, HITL, provides that absolutely critical safety check.
Look, this technology is moving incredibly fast. It's leaving the research labs and jumping right into real-world products. So the next great challenge isn't just about building more powerful agents. It's about creating the systems and the guardrails to manage them safely and wisely. The era of agentic AI isn't coming. It's already here. The real question is, are we ready?